Bonjour. Alors nous allons commencer la prochaine session. Nous avons la chance d'accueillir Alexis Gutiérrez, un expert du BRGM, et nous allons parler de nappes phréatiques.
Comment on passe les diapos?
Ah oui. Le cliqueur juste ici et puis vous pouvez
Revenir en arrière.
revenir en arrière avec
Et ça pointe.
normalement, ça pointe, oui. Exact. C'est pas hyper fort.
Non, je vois rien du tout. Il faut peut-être activer quelque chose.
Voilà.
Ah oui.
Alors, en fait, sur les écrans, ça marche
Ah oui,
pas.
oui.
Voilà.
Bon, je montrerai avec les doigts.
Avec la main, ouais.
Merci, bonjour à tous. I'm going to make this presentation in English. I should present with somebody from the Namibian government. I don't know if this person has arrived. Is there anybody from Namibia among us? It seems this person is not here yet. Anyway, this study was done by BRGM for the Namibian government under an agreement involving the Ministry of Agriculture, Water and Land Reform, and the Ministry of Environment, Tourism and Forest. Under an agreement signed with the French Agency for Development, AFD. This is a study which tackles the climate change aspects. It intends to evaluate the resource and best ways of exploitation of local aquifers in Namibia, in northern Namibia, now and at mid-term at horizon 2050. This study encompasses the computation of the recharge of aquifers, which means compared to the climate change, what is the impact of climate change on the recharge infiltration to the aquifers, which allows us to compute the groundwater resources and from the groundwater resources estimate the sustainable resources. From the sustainable resources, comparing with the water demand, estimate the water stress of the area. I don't know. So we have two regions here. We are in the north of Namibia. Namibia is just north of South Africa. This is one of the driest regions in sub-Saharan Africa, with two contrasted regions. The Kunene region is the region of hilly and mountainous landscapes. It's very wild regions with the Imba and Damara tribes. The economy is based on crop breeding, livestock breeding, no crops. There is no river. The only river is in the north. It makes a border with Angola. And the density of population is very low. It's a very nice country, very nice area. The tourism is developing, as well as mines are, because it's rich in various metals. In comparison, the Omusati region to the east is a different landscape. It's completely flat. It's part of the Kalahari Desert. The population is 10 times more than in the Kunene region. It has no river, but sometimes during the year there is runoff coming from Angola, and it's flooding all the area during a few weeks, or few days, or to several weeks, as you can see on the picture. And this flood is benefiting to the area. The people can do crops, and the water goes on to the Etosha Pan. Maybe people among you know the Etosha Park. The Etosha Pan, which is here, is a lake, salt lake with a very low depth. So the region is economically more viable with crops, as I said, with livestock as well, and some manufacturing and tourism activity. If we speak about the hydrogeology and the geological aspects, we have hard rocks formations in the eastern part, in the western part, sorry, which are of low potential. They are in brown here, and when we go to the east, we come to the sedimentary basin, which gives good potential aquifers, which are in blue here. And the landscape, the relief, the mountainous relief, is marked by the presence of a dolomitic belt, which borders the sedimentary basin, and where recharge can occur. So we have contrasted rainfall as well, with 50 to 300 millimeters rainfall to the western part. And in the sedimentary basin, the rainfall is significantly higher, 300 to 500 millimeters per year. So it gives high potential to the aquifers, but it is salt geological formations, so the water quality is unfortunately not as drinkable standards. So except in the north of Omusati, in this area, sorry, it has shifted a bit. The north of Omusati here is supplied by water by the river with a canal coming from Angola. But all the other areas are depending on groundwater for their water supply. So we have computed the recharge. To evaluate the groundwater recharge, there is many methods that we can use, but we have chosen to use the water budget method. This water budget method computes first what we call the effective precipitation. So it's a bit technical, but it's the effective precipitation is no more than that the precipitation minus the water which goes back to the atmosphere by potential evaporation and transpiration of plants. So you remove this evaporation from the precipitation, you get the effective precipitation. Then the effective precipitation, we will divide it into runoff, which goes at the surface of the earth, and infiltration, and this infiltration is what we are looking for. We have graded all the area, all the northern Namibia is graded with meshes 28 by 28 kilometers. And in each one of these grids, these meshes, we have taken the climatic parameters and the soil parameters from existing databases. These existing databases, we can find them on internet. We also interpret some satellite imagery to get first the evapotranspiration, the rainfall, the soil and land use, and the soil water storage. Those parameters which are considered in the computation of the effective precipitation. I won't go into details because we don't have time, but from this effective precipitation, then we need to divide the part which goes as runoff and the part which infiltrates. And this is done by considering the geological layers. We have geological maps, and we made also field work so that we can decide, arbitrarily decide, using also the literature, the former studies, whether this type of geology is able to infiltrate water or not. So we give a coefficient of infiltration, and we multiply this coefficient, which is between 0 and 1, by the effective precipitation that we have found to get the recharge of the aquifer. Therefore, the recharge of the aquifer, as you can see, is extremely low. Of course, it's very low because you have very low rainfall, but it's very low also in certain areas because the rocks are very hard and do not allow the water to infiltrate. So all the red areas here, those are areas where the recharge is null or almost null. The only areas where we have recharge are volcanic terrains, which are in the south of Kunene here, and the sedimentary basin of the Kalahari Desert. So already we can see that there is a problem of water because there is, before applying the climate change impact, we see that there is already a problem of water quantity. So on the left side, the recharge is expressed as a percentage of precipitation. On the right side, it's expressed as millimeters. Everyone can see that those figures are very low. The average of recharge in Namibia is 1% of the precipitation, and 1% of a low rainfall is a few millimeters. So we are dealing with a few millimeters of recharge per year. Now we want to consider the impact of climate change. So we compute from the projections of the RCP 8.5, we computed what would be the recharge in the next 30 years, which we call midterm, and in the following 30 years we call long term. At the midterm, we can see on the left it's the result of the map, but the right map is more expressive. It shows the difference between the present and the computed recharge. So in the 2050s, we'll have an improvement, a slight improvement of recharge in the central part of the mountainous Kunene, and a global degradation in the eastern part. This is the result of the projections of the rainfall, and in the 30 years following, we'll have a general degradation of this recharge due to a general decrease of the rainfall. So it was a bit of a surprise to see that there was an improvement of the recharge with the climate change in this area, but we have to stress that this improvement is really slight, very, very little improvement, and only on the western part. And all the gray areas, there is no improvement because there was no recharge before, so zero stays zero. Cannot, well, no improvement nor degradation. If we consider the volumes, maybe it's more understandable when we speak about volumes of recharge. The current recharge is estimated as more than 700 million cubic meters per year. In the next 30 years, this current recharge will slightly decrease. We have seen that in some areas it's improving, but others are degrading. But in the long term, at the end of this century, we have a sharp drop of the recharge. It's really impressive. It's almost half. It's 42% of recharge decrease by the end of the century. Continuing the study, we have revised the existing hydrogeological map And this work was established with the most recent data. Then the potential of the aquifer is estimated very low in the eastern part, as I said earlier. And we can see it by the brown colors, and much better when you go east towards the sedimentary basin. The sedimentary basin, it's high thickness of sands, so we can understand that it can bear water easily. Unfortunately, this sedimentary basin is salty. We have problem of salt, but also of fluoride and of sulfates and also nitrates. So all the areas which are dashed here are not prone for a water supply. It's not drinkable water. So they not only have a problem of quantity, they also have a problem of quality, of water quality. And the areas where there is some water available, this water, most of it is not drinkable. It means that if they want to pump this water, they need to process it, to treat it, and of course, they cannot afford it for most of the population, which is rural population. There is no treatment plant for the water supply. So we can see that the aquifer potential, which has been computed, must be now compared to the recharge that we have computed earlier to know the quantity which is available. This is what we call the available resource. And from this available resource, we have to remove the part which is used for other services than the human services. I mean, the wetlands, for instance, which are an ecosystemic service. Thanks to the wetlands, we have wildlife. Thanks to the wildlife, we have tourism, or we have also other services. So we only take part of this available water, which is computed by mixing the aquifer potential and the recharge. And this gives a sustainable groundwater resource map. And the sustainable groundwater resource map, we compute it for the next 30 years and for the next 60 years. And we can see that if we make the difference between the future and the present situation, at midterm, the situation is degrading. Hello. The situation is degrading in the eastern part, all the Etosha basin, but also in the eastern part of the Kunene area. It's not degrading in the central part because of the higher recharge that they will get at midterm. But in the long term, on the long run, the degradation is total, all the country. And again, the white areas is because there is no water at all. So it cannot degrade more because there is already zero water available. Now we have to compare this groundwater availability with the water demand. Fortunately, I would say in the eastern part where there is no water, there is nobody. And there is a consequence, I suppose, of this situation, which is not new. The water demand is higher in the northeast, where it is more industrialized, and it's also the area which is irrigated, and the water is supplied from the river, the Kunene River, coming from Angola. So this part in the north has a high groundwater, has a high water demand, total water demand, but it's supplied by surface water. All the rest has to be supplied by the groundwater, and you can see that the water demand is augmenting, is increasing at the projection 2050. We didn't project more than 2050. It's not reasonable to make projections of water demand on a so long term because We don't know what will be the infrastructure. We don't know what will be the evolution of economical activities and so on. Therefore, this is the result of this part of the computation. We also made in the study other economical aspects, but I will not present them here. The water stress index is computed according to the SDG 6.4.2. It's the comparison of the water demand and the water resource. We can see all the red areas are areas where the water stress is more than 100%. All the dashed areas are areas where the quality is bad, so you cannot use this water unless you pay a lot for its treatment. So the only remaining areas where there is water are along the dolomitic belt here, an aquifer, carbonated aquifer, which gets more recharge, or which gets a little bit of recharge, and volcanic areas here where there is nobody. So it's for that reason that it stays green with less water stress. If we consider the water stress, this is the present water stress in 2050. Of course, the situation degrades, not only because the recharge decrease in the eastern part, but also because of the growth of the increase of the population. So, despite the fact that we had more recharge in the Opuo area, in the central part, because we have more people, the stress is still increasing. So as a conclusion, our statement is that by 2050, the population will increase by 24%, and the rural domestic water demand is expected to grow by 42%. It's an important increase. The services to supply this population will develop accordingly, and the agriculture development is very, very limited. There is no water available for agriculture in these areas, except in the northern part where there is this canal which is giving some water from the Kunene River. But most of the area has no perspective of development of its agriculture. And all the cities of the Kunene regions will face very severe groundwater crisis. In the rural areas, the demand may stay sufficiently low to avoid major issues. So there is some water available, but because there is a very low density of population and not so much increase of population, it's still sustainable. But there is a big problem that is, first, the tourism. There is more and more tourism, so they need water, and there is no water available for more water demand from tourism and the mining industry. And there is a lot of mining prospection investigations in this area today that will give tomorrow, and when I say tomorrow, it's in 2024, not at long term, new mines which have a very high need of water. And the only source of water here is groundwater, so there is no groundwater available, so they will need to take water from probably the river hundreds of kilometers in the north, or the sea, hundreds of kilometers in the west, but with a very high denivellation, very change in elevation. It's more than 1,500 meters of between the sea level and the mining activity. So maybe that's the chance for the population, that mining activity, finally, because they are the only ones that have the money to make such big such big development for bringing water and treating water over there. To finish, the Umusati region has a very low quality of groundwater, but we have some indices, some ideas that deeper we can find fresh water, and investigation need to be done to confirm this hydrogeological hypothesis. So I want to thank you for your attention, and again, if my colleague from Namibia is here, but I don't think they went. Okay, thank you.
Thank you. I have questions, but maybe other people have questions as well. I don't know. Yes, of course.
Okay, yeah, thanks. So my name is Ilham. I'm from Indonesia. My first question will be: climate change affects very big to our quantity and quality of groundwater, right? And can we can we generalize that climate change is like the biggest factor of the quantity and quality changes in groundwater? And then my second question is: I'm coming from Sidoarjo in Java, Indonesia, and we have a big disaster there, the biggest mud volcano in the world. And we analyzed groundwater quality there, and we found that there is also some heavy metals there. And my question will be: do you have any brief suggestion for us, like which kind of method that we should apply to process groundwater to make it drinkable? Because we still have this kind of system, so that's why it's really nice to learn from you. Thanks.
Okay, thank you for your questions. Unfortunately, I won't answer the second one because I'm hydrogeologist. I'm not familiar with all the water treatments, but I'm sure in the forum you will find specialized people. Regarding your first question about climatic change, my opinion is not that it is not climatic change that is the biggest threat on the groundwater resource. The major impact is from the growing of the population and the growing of the activities. We have seen that climate change may also improve in some areas the conditions, but when considering the water demand, the whole country is degraded. So for me, and in this region, it's not climate change the major problem.
Est-ce qu'il y a d'autres questions, other questions? Me, I was wondering, we don't have the map anymore, but I was wondering what caused the presence of sulfates and what is the other?
Fluoride.
Yeah, what
Yes.
caused it? Thank you.
We have gypsum layers in the sedimentary basin, which are responsible for sulfate and fluorides. And in the Kunene area, we have also fluorides in the hard rocks formations. It's very common in Africa to have fluorides high concentration in hard rocks formations. So it's major problem of water quality, not only in Namibia.
We've seen that for those who know Namibia, the coast is very hostile.
The skeleton coast.
Skeleton coast. I've been there, so I've seen it with my eyes. It's very striking. Yeah. But do you know if they're considering desal to supply water to the country, or desalination, or because they are in a very critical situation, and
there is a desalination plant in Trécopier, which is a former mine for uranium, and this desalination plant already supplies the city of Swakopmund. It is planned. There is a project to boost this water to Windhoek, the capital of Namibia, So it's a few hundreds of kilometers, but a high elevation difference. The other project to supply Windhoek is to extend the canal from the Okavango River. So both projects are very criticized on environmental aspects, of course, but it's far from the area where I worked. Yes, in the northern part of Namibia, there is no project for desalination yet, but there might be some projects one day if they want to develop mining activities.
Because the Okavango River is already a river that is not reaching the sea.
No.
So it's already...
It's a big problem. It goes to Botswana, where there is a big delta, inland delta. And if the Namibian take from the Okavango, of course the Botswana people do not agree with that. They could take from the Kunene River. They have an agreement with the Angola, and they did not reach the maximum quantity in this agreement. So they want to take a new canal from the Kunene River to supply the northern part of Kunene that I showed. This could be a solution. The only problem is that Kunene River also has low periods of water. And when we think globally, we say, yes, there is water available, but this water is not available all along the year. And it will not solve all the problem, but at least it will improve a little bit the situation, yes.
And the Kalahari region, which is from the French standpoint already a desertic area, there is a chance that there is fossil groundwater or some groundwater?
Yes, I would not call it fossil groundwater. I think this is a big sedimentary basin which extends in Angola, and Angola has a much higher rainfall than Namibia. They have hilly areas where there is important rainfall. They provoke this flooding towards the Etosha Pan every year, and most of this water, not most, but part of this water infiltrates. And it infiltrates in Angola, but the aquifer may be continuous, and we may have deep layer of sand which contains fresh water. It's old water, of course. It's very old because the water goes very slowly, but it's still it would be still furnished or re-alimented by the rainfall in Angola. The German cooperation has drilled boreholes in the eastern part of the basin, and they have found water at 400 meters deep, which is of good quality despite some fluorides. So yes, there is hope by drilling deep wells to supply part of the Omusati area.
Thank you very much. It was really, really interesting, and the presentation is available for whoever is interested. Thank you.
Thank you to Partenariat Français pour l'invitation. Merci.